fit me data. Top machine learning to all the smartest kids doing. All the H1B visas are doing. Don't you think machine learning saw that and danced wild? Well, it's not that sexy. In fact, let me strip it down. Machine learning is just trial and error. But why? How does machine learning work? There are different types of machine learnings, but they all respect the same process. We'll go through the process first, then we'll go for an example. So don't worry if you can't digest everything. When I say don't worry, I mean don't give up on my video. I will literally show you machine learning with a pen and a paper. The process happens in three main phases: data pre-processing, training the model, and evaluating the model. Data pre-processing. This is where we take raw data and clean it up. We have to prepare the data. So this includes filling in any missing information, making sure everything's on the same scale, converting text into numbers. Second, training the model. After preparing the data, we split into two parts. One for training the model and another one for testing the model. So usually 70 to 80% of the data is used for training and the remaining 20-30% is for testing. During this training phase, the model looks at the data and tries to figure out patterns or connections between these inputs and the expected results. It does this by repeatedly adjusting itself to get better and better at predicting the right outcomes. And we'll see this. Once the model is trained and it shows high accuracy and small error, then it's time for the third part, evaluating the model. The goal here is to make sure that the model works well on new data, data that wasn't trained on, so it can actually be applied in the real world. We use our test set, the 20-30% of the data that we held back earlier, to see how the model performs on this data that it hasn't seen before. We use different methods to measure its performance, such as how many times the model is right or how close to zero is the error. This helps us see if the model is actually very good at making predictions. Let's see an example of how this works. I need a pen. Let's create a machine learning model to estimate house prices. First, data pre-processing. We collect data on a large number of houses, millions, including their size, number of bedrooms, location, age, prices. To simplify, you're gonna have just one feature. The price of houses are a relationship of their size. House A, B through Z. So our data set would have 296 data points. Let's say that a house that is 1,000 square feet costs $3,000. A house that is double the size costs $6,000. If this is the only relationship, we know that the parameter is a 3. If we have 1,000 square feet times 3, it's $3,000, and 2,000 square feet times 3, it's the $6,000. But the computer doesn't know. This is what our machine learning model needs to estimate. We need to make sure that all of our data is in square feet. All of this is USD, and of course, in the reality, we would have the same location. We would make sure the data is all as of the same date, that we have way more than just 26 days. So next, we train the model. We take 80% of the data and we'll let the computer learn the relationship between the house features and the prices. We are trying to say, look, computer, you have house A and house B. Can you help me find this equation? Price equals, we're gonna call this beta, a parameter, and the size. Run it. And it's literally a trial and error. Let's do first run for you to understand. So let's say run model 1. The parameter always start as 0 and then it changes. First trial, the computer says parameter beta equals 1. Now, what the computer is going to do, it's going to go to house A. If I input beta times, no, this is 1, sorry, square feet, it would give us $1,000. And for beta, this is 1. This house, it was a 2,000 square feet, it would give us a $2,000. The computer would compare to the actual. If there is an error of $2,000, there is an error here of $4,000. If you ever taken a statistics class, you were like, aha, I've done that. I had that moment too. Guess what? Linear regression is machine learning. Wouldn't you have paid more attention to the statistics class if it was named machine learning? there's a real problem going on in economics, but not in computer science. Artificial intelligence, machine learning. The model will run again, and now let's say parameter is 2. So something interesting has happened. Still there is an error, but an error that is smaller than our previous, which for the first house was $2,000 and for the second house was $4,000. The computer is learning. This is the learning in machine learning, the process of minimizing the error between the model's predictions and the actual results by adjusting the model's parameters. So whenever we say learning from data, we actually are saying
minimizing the error between the model's predictions and the actual results.
And that's what the computer will do for way bigger data sets and using, of course, like numerous features. Here we only used the size. So the model keeps adjusting itself, learning from its mistakes and getting better and better at predicting the prices based on the data it has seen. Let's say we got the parameter 3, we have a model. Finally, we evaluate the model. So now let's get our 20% of the data that the model hasn't seen to test if the parameter will work in our test data. Let's say house C and D, the size of this is 3,000 and the size of this one 1,500 square meters. And we know the prices are $9,000, $4,500. What the computer is going to do? Test the model. But now this model is the model that has been developed during training. The parameter doesn't start as 0. The parameter starts as 3, which was the parameter that the computer arrived at during training. 3 times 1,000 square feet, house D, and 9,000 here, predicted price of the computer, and perfect. This is it. This is our model. So now you know how to run the model. And that's essentially how Zestimate on the Zillow website works. Whenever you're looking at a home on Zillow, you see the price requested by the owner. And below that, the Zestimate, the estimated fair price of the home. Lastly, I want to address a question that I had. What makes a machine intelligent? When a programmer writes a code, they know exactly how the system will behave in any situation. The system itself has no intelligence. It simply follows the programmer's instructions, with speed being its only advantage. In machine learning, however, the model's behavior can be predicted at the time of training. Once it learns from data, it develops something that we may call intelligence, since it goes beyond the original data sets. The model will be able to be applied to data that it has never seen before. Sometimes even provide solutions that the programmer never anticipated. In this way, the machine learning model can be said to have acquired intelligence beyond what the programmer directly provided. Data now drives entire operations and also entire large language models. ChatGPT, Gemini, Llama have practically read the entire internet. All these large language models need even more massive amounts of data. But why?